According to physics, energy cannot be created or destroyed. Yet somehow our universe contains an unimaginable amount of energy. So here's the question. Where did it all come from? To find out, I'm going to raise 6 important questions. Question 1. Did the Big Bang create energy? Question 2. Doesn't that violate the laws of physics? Question 3. What does Einstein's famous equation have to do with this? Question 4. Why do physicists talk about negative energy? Question 5. Could the total energy of the universe actually be zero? Question 6. If the universe keeps expanding, does the balance still work? Let's answer them one by one. Question 1. Did the Big Bang create energy? At first, the answer seems obvious. After all, the universe began about 13.8 billion years ago in an extremely hot and dense state. But is that really the whole story? Today, the universe contains hundreds of billions of galaxies, trillions of stars, and unimaginable amounts of energy. So surely the Big Bang created all that energy. Or did it? There's just one problem. According to most important laws in physics, energy cannot be created or destroyed. It can change form or move from one place to another. So where did all the energy in the universe come from? But energy cannot simply appear out of nowhere. So if energy cannot be created, where did all the energy in the universe come from? To answer that question, we need to talk about Einstein. In 1905, Einstein discovered something remarkable. Matter and energy are actually 2 forms of the same thing. Einstein summarized this idea with perhaps the most famous equation in history, E equals mc squared. In fact, the sun shines because tiny amounts of matter are constantly being converted into energy. That energy travels through space and eventually reaches Earth. Every ray of sunlight carries energy that was once mass inside the sun. To produce its enormous energy output, the sun converts about 4 billion kilograms of its own mass into energy every second. That's about 4 million tons every second. And that process is happening even right now. Over a single day, that adds up to roughly 350 billion tons. Yet the sun is so massive that it can continue shining for billions more years. The sunlight reaching Earth today was once mass deep inside the sun. Every sunrise is a reminder of Einstein's remarkable discovery. So does that solve the mystery? Not completely. Einstein's equation explains how mass can become energy, but it doesn't fully explain where all the matter and energy in the universe came from in the first place. And that's where the story becomes even more fascinating. Some physicists have proposed a fascinating possibility. What if the positive energy contained in all matter is balanced by something else? What if the universe keeps its books balanced? And if that's true, the answer to our mystery may be more surprising than you think. Matter contains positive energy, but gravity may contribute something very different. Many physicists describe gravity as contributing negative energy, and astonishingly, those two might cancel each other out. If all the positive energy in the universe is balanced by gravity's negative energy, the total energy of the universe could be zero. And that changes everything, because if the total energy of the universe is remarkably close to zero, then creating a universe may not require an enormous energy budget after all. Some physicists have suggested that a universe like ours could emerge from a tiny quantum fluctuation. Not from absolutely nothing, but from the strange quantum rules that govern empty space itself. According to quantum physics, even empty space isn't truly empty. Tiny amounts of energy can briefly appear and then vanish again. These events are known as quantum fluctuations. But what if one didn't disappear? What if it kept expanding? Could that become an entire universe? Some physicists have suggested that something like this may have happened nearly 13.8 billion years ago. A quantum fluctuation may have played a role in the birth of our universe. This remains a scientific hypothesis, but it offers one possible explanation for how a universe could emerge from a quantum vacuum. And the search for the true answer continues, because the greatest mysteries of the universe are still waiting to be solved. But perhaps the deepest mystery of all is this: why do the laws of physics exist at all? Why does a quantum vacuum exist? And why is there something rather than nothing? After centuries of discovery, we have learned an astonishing amount about our universe. Yet its deepest mysteries remain unsolved, and perhaps that is what makes science so exciting. Every answer leads to a new question. The answers to all 6 questions we've explored today are summarized here. Some answers are supported by strong scientific evidence, others remain active areas of research. But together, they reveal just how extraordinary our universe truly is. The universe still holds countless secrets, and every discovery brings us one step closer to understanding it. Until next time, keep exploring.